we're going to have a intro to Tim's Celt talk, an update on the state of the Theora codec, an update on the state of the Dirac codec, and some info about the video accessibility project that Sylvia is doing for OGG for Mozilla.
Where the slides?
Sorry.
Right. So I'm going to give a brief update on OGG Theora. This is obviously joint work with Ralph Giles and Monty and the rest of the Zif.org team. So in the past year or so, our native support in Firefox has progressed into the beta releases. We're still also included in experimental opera builds, and those are now moving towards a full release. And we actually released version 1.0 of libtheora, which was nice. The actual file format and the decoder had been stable for years at this point, but we had big plans for the encoder to get quality improvements into that, so we hadn't made the jump to 1.0, but we finally realized that was holding us back. And so we've made a 1.0 release with the encoder as it currently is, just so we can make sure to get distribution of a decoder that will support the new features that we're planning to add in the new encoder. So we've been shipping a new decoder since beta 1, which supports the full format specification that we published in 2004. But the new encoder, the old encoder, has not actually used a number of those new features. So we're now working on a new encoder that will use those features, so we're hoping people will upgrade their decoders now, so that when we release 1.1 with Monty's new Thesnelda encoder, then we'll already have player support out there for those features. So the goal of the Thesnelda project is to update the original VP3 encoder that we inherited from On2, using a lot of stuff that people have learned about video coding in the 10 years since that was written. We've learned one or two things. So I actually wrote a completely separate Theora encoder implementation called Theora EXP. EXP was for experimental, so some bits of that were good and some other bits of that were very bad, didn't work out. So we've taken the good bits and folded those back into the old VP3 encoder and have done a number of other improvements to that from there. And so that's become the new base for Thesnelda. So we're going to be we've done new rate distortion optimization, and that gave us a big boost in quality, so that we're actually much more competitive with things like Xvid and other codecs like that. So we've gotten a lot of good results out of this project so far, but it's still an engineering prototype at this stage. So there's no real proper rate control. There's a number of hard-coded constants in the code, and there's still a few missing features. So our plan is to get that cleaned up over the next 6 months or so and get that released as version 1.1. Monty apologizes profusely since about Thanksgiving. Red Hat has been making him work on a completely different project, but hopefully that should be out sometime soon. So the next steps for the project, on the decoder side, we need to move forward with ARM and DSP optimization for stuff like the Nokia N800, N810. We also talked about at FOMS getting OpenMax integration, which OpenMax is basically the GStreamer for the DSP side. And so if we can get support for our codecs into there, that will enable its use in many more DSPs and a lot of existing software that uses OpenMax. For the encoder side, the plan is obviously to make Thesnelda the new mainline encoder for version 1.1. There's still a bunch of work to do to get that done, but I think we have a plan to go forward. And on the adoption front, we want to get Opera and Firefox integration completed. The codec issue in HTML5 is still not resolved. If you recall, last year Theora had been recommended in the draft HTML5 standard and was removed. So that's still the current status, but it's still a draft standard. We're going to be working on the patent side to try to counteract the FUD that's been spread about patents in Theora. But in the meantime, getting support in common browsers like Opera and Firefox will give us a much better chance, in the sense that a de facto standard is better than nothing at all, which is what HTML5 currently offers. Also want to give a brief preview for my talk on Celt, which will be on Thursday in this room. So Celt is a new audio codec. The goal of the project is to deliver CD quality audio with speech codec latency. So there are two main types of codecs. The first class is where Vorbis and MP3 fall in. That's the kind you may be more familiar with. Those generally require hundreds of milliseconds of audio before they can output even one compressed packet, so you have this huge latency. Speech codecs, on the other hand, which are used in GSM and Skype and other things like that, they have good latency, in the range of 25 milliseconds or so, but they operate with much smaller sampling rates, so in the 8 kilohertz to 16 kilohertz range, which means that the frequencies they can represent are about half of that, which is much less than the human ear can hear. So they have poor quality. So, and the unfortunate part is the techniques they use don't scale well to high sampling rates. And similarly, the techniques that Vorbis and MP3 use have efficiency problems when you start using smaller chunks of audio. So we invented a new codec called Celt. This was primarily, the project lead is Jean-Marc Vallin, the guy who did Speaks. And so Celt is designed to give low latency with good quality. So it operates at CD quality sampling rates, but gives you latencies in the range of 5 to 10 milliseconds. So that allows you to do better voice over IP, better video conferencing. You can do distributed live music, where musicians around the country are playing together. And the talk will cover the basics of that design. We'll show some listening test results so you can see how we perform with other codecs. And I'll also talk about how to use the library so you can integrate Celt into your applications and various other things. So everybody come along to that. It'll be a good time. Fun will be had by all. And that's the end of my spiel. Are there any questions before I?
Cool. Thanks, Tim.
Hi, I'm Manu Surupraju. I was part of the Dirac team. I was with BBC Research until September last year, but now I'm working as a contractor for them. And Dirac is a royalty-free compression technology. It's aimed at right down from internet streaming applications right up to digital cinema. It's also video compression format. We have released two versions of the specifications. I'll talk more about that later, version 1.0 and version 2.0 of the specifications. And anybody can implement these specifications either in software or hardware. And we've also released two versions of the software. We have the one being developed at the BBC. Oh, sorry. The one being developed at the BBC is known as the Dirac Research Software. That's mainly used for algorithm development. And we have an optimized version of the software as well called Schrödinger, the Schrödinger implementations. And both of these can be downloaded and used for free from the diracvideo.org website. And we also have production software aimed at easing the transition from SD production to HD production. That's not something that the BBC is developing it in collaboration with New Media Technology, who's the hardware partner. I'll start off with a brief history of Dirac as well as just a very brief description of what the codec is all about. It originated from HDTV compression experiments in 2001 and 2002 because BBC wanted to make a transition to HDTV production, and you needed a better technology than what was existing at the time. And the first version of these experiments was released in 2004. And the Dirac project was released on sourceforge.net. And in 2006, that particular application, though it was technically good, offered good compression performance. Unfortunately, it was not optimized for everyday usage. So BBC decided to commission a project with Fluendo to develop a real-time optimized codec, and that's a Schrödinger codec that came into being in 2006. And in 2000, and when they wanted to move, BBC was also, when it's trying to move to HD production, it was also doing research into a high-quality codec for transporting large amounts of data between studios. And in late 2006, it was decided to merge the low bitrate Dirac codec with the high-quality production codec and produce just one stream of codecs that can handle all these different bit rates. So essentially, you have two syntaxes here. One's the low delay syntax, that's for production, used in production and archiving environment, and we have, and then Dirac, which is used for, and the core syntax that has higher compression, and can be used for lower bit rates. So the technology used in Dirac is a conventional hybrid codec architecture, and it uses motion compensation to predict pictures from earlier pictures, and this motion this is used for compressing for temporal compression, and uses wavelet transforms instead of block transforms for spatial compression, and it uses overlap motion compensation to smooth out any block edges. And these block usually you can use variable length block sizes, and the amount of overlap also can be determined and can be set by the user. So it's fairly flexible. The encoding is fairly flexible. This is, as you can see, this is the standard hybrid codec. I'm talking about the low latency syntax and co-syntax. The low latency syntax in Dirac that doesn't use wavelet transform, but rather uses slices, and so to minimize latency, and it doesn't use arithmetic. It doesn't use arithmetic coding, but uses variable length codes. Whereas the co-syntax can use either variable length codes or arithmetic coding, and it also uses motion compensation. Whereas the low latency syntax is intra only. Now to what's been going on with Dirac over the past year. We finally released the Dirac specification in January 2008, so the bitstream was frozen since then. And it's been designed in such a way that you can add on to the existing bitstream without affecting the older version, so it is backward compatible. And the specifications can be downloaded again from diracvideo.org, and it describes the specification describes the stream syntax as well as entropy coding and coefficient unpacking and the decoding processes. And there's some pseudocode available there as well, but it's really not very optimized. The pseudocode is just to explain the internal workings of the codec. The optimized implementation was released of Schrödinger was released in February 2008, and this implements both the low latency syntax as well as the core syntax. And the Dirac research software, which implements only the core syntax, was released in September 2000 last year. The main thing was to add, for adoption of Dirac, we wanted to add support to as many multimedia applications as possible. So lots of work was done last year to add Dirac support to FFmpeg. You can encode and decode in FFmpeg using Schrödinger as well as the Dirac research codec. And then we had an application clone from FFmpeg to Theora called FFmpeg to Dirac that can wrap Dirac and OGG with OGG with OGG warblers and OGG format, and plugins for QuickTime players and direct show filters for Windows Media Player, then encoding and decoding using VLC, and added Dirac support to ZIF and analytics libraries as well. The portal for Dirac information is diracvideo.org. There's quite a lot of information is there. Some of it is outdated, but we try to keep it as up to date as possible. And we have various Dirac mapping specifications as well to different formats. So you have it for the OGG for the OGG format, for MPEG-2 transport streams, for AVI, Matroska, and for the QuickTime one as well. I forgot, it's called ISOM, is it? For the QuickTime format as well. And Dirac hardware for production hardware was released, available commercially from New Media Technology. Currently, there are 3 implementations of the low latency syntax. You have the Dirac Pro 270 that can transport HD over standard definition links, which is very useful because most of the studios don't need to upgrade their production environment from standard definition to HD, so that's very helpful there. And you have the Dirac Pro 1.5 that compresses full HD, that's HD P50, so that you can use just regular HD SDI links rather than full HD SDI links. And the Dirac Pro 221 that muxes 2 HD links over a single HD SDI. So there was a practical use for Dirac Pro 270. It was used as a Beijing Games, other than the Olympic, not on the Olympic green, but for all the other for all the other venues. And what it was you captured you captured the video, then compressed it using Dirac, and then transported over the Dirac Pro over SDI links, and then decoded it, and then used it in the production environment. So that was the first usage of Dirac in a production environment. So that it worked out quite well. So BBC has purchased a few of these Dirac Pro 270 units, and it's going to use them in its television center for HD production. And these units have been purchased by other organizations as well. Like the one in the Austrian broadcaster is going to use it for its outside broadcasting, and NHK, the Japanese broadcaster, is just evaluating that particular product. And the other usages of Dirac at NHK, like NHK is producing a format called Super High Vision, that is either 4 times, it's going to be a 4K format and an 8K format, which are something like 4 times the size of I think 4 times the size of HD 1080p 60, or 16 times the size. And it wants to use this information not only for commercial production, but also wants it to stream it into the houses using a 70 megabits per second satellite transponder with the surround sound, 22.2 surround sound audio. So they need a good, and so at the most you have to use around 60 to 62 megabits per second for audio. So they had performed experiments using, they have hardware using MPEG-2 and H.264 HD. And they were able to compress, I think, up to 140 megabits per second using pretty static images. So they were experimenting, they conducted some experiments using Dirac as well, the existing version of Dirac. And at IBC last year, they were able to demonstrate pictures at 128 megabits per second. So further research is going on to this area. Like Dirac probably will not be used in the final, if it's going to be, it will not be used in the final experiment. There's something based on Dirac. What we learned from using Dirac is going to be used. It will probably be used at NHK. But quite a lot of good came out of these experiments at NHK, because all that information was, all those results are fed back into Dirac to make it a better, the existing Dirac to make it a better product. The next steps of Dirac, we started the standardization of the low latency syntax through SMT, known as VC2. We're still continuing with it. We're going to produce, I need to produce a few more bit streams, I think test streams and reference software for that, and the standardization process is going to continue this year. And we hope to standardize the core syntax through SMT as well, either this year or later, or sometime later next year. And we're working on algorithm improvements and, like I said, towards both in hardware and software side of things. So one of this is for NHK and for using of Dirac within the BBC network to transport hardware, to transport compressed compressed video. And planning a Dirac RTP specification that's in the pipeline. And so far the hardware has only been the low latency syntax. So planning to implement the core syntax as well, because the low latency syntax doesn't offer that, the compression ratio is very low as well. So we're going to trying to have the core syntax without, that's only iframe only and no arithmetic coding, to offer at the first step, to offer higher compression ratios. And it's also implementing ASI and IP input and output for Dirac Pro, which is essential for if Dirac is going to be used within the Raman network in the BBC. So for working towards that, we're trying to implement both ASI and IP outputs. It's standard. I don't have that much information about that either. It's just for broadcast equipment like SDI. You have another format as ASI. I'm sorry, I've forgotten the full form of it, as I'm not very good with abbreviations. For those steps in Dirac software development, like Sylvia had already said, we're going to work with Dirac support in libOgg Play so that it can play back Dirac straight using Firefox. And currently we have the Schrödinger codec, but the compression quality of the Schrödinger codec is not up to mark yet. So lots of work is being done in motion estimation. It's only, I think at the moment only supports half pixel motion estimation, so we are motion vectors, so we are working on the motion estimation side of things and the ray distortion optimization. And that's going to, probably that work will be done by March this year. And once the Schrödinger is up to mark, Schrödinger codec is up to mark, you can just stop using Dirac Research codec altogether. But any work that's being done on the Dirac Research codec to improve the algorithms, that will always be fed back into Schrödinger. And we're working on a direct show filter for production use. It's still in the development, design stage. And we do have filters for use, but they mainly at the moment that are open source filters that are out there at the moment, they're only for playback. But we want it for used for encoding and in production use itself for editing purposes as well. So, yep, any information you need on Dirac, please go to diracmedia.org. Any questions?
How far is the work for integrating Dirac into the play?
So I need to submit a patch to it, and I think that we did do a bit of hacking on it in forms, during forms, and there's some bugs need to be ironed out. So we're working on it for the next couple of days, and hopefully in the next couple of weeks or so, it'll be in there. Yeah.
So what's the performance of Schrödinger looking like now? Is it feasible to decode, 1080p, 24 frames a second video on a mid-range PC?
Yes, decoding wise it is, yes, but encoding, I think to code HD you need a quad-core machine to encode it. We're still working on that, yeah, that optimization, the speed part of it, we're still working on it. But decoding, yes, it is, I think with the dual core you should be able to get real-time decoding.
With the take-up of Dirac, you said that NHK in Japan is taking it up. There's a there's a network in Austria that's taking it up. Is there anybody in Australia that's even shown interest?
I'm not sure. No, I don't know much about that. Sorry. But I guess if the BBC is using it, it'll get that's going to give it some. It'll make it more popular, I suppose. Yeah.
Panasonic website is advertising the fact that ABC Australia no, not Dirac, picked up Panasonic's whatever their sort of system is. We didn't
I guess against the distance there. So quite a few of the European broadcasters are showing interest in Dirac for HD production, but yeah.
I'm curious whether there's any prospects for getting it onto a kind of optical format or something. I guess the current generation of stuff is already out there, so yeah. I just
Yeah, there's something to feed back to the Dirac team, I suppose.
Do you have any plans for Dirac 2?
In the pipeline, yes. There's work going to go on the future of video compression in general. Work is going to go on, yeah. But like I said, right now I'm not a direct employee of BBC, so I'm not privy to most of that information. But you can get in touch with either on the Schrödinger mailing list or on Dirac forums. Get in touch with the Dirac team, and they'll get back to you.
What kind of latency does Dirac introduce? Is it suitable for video conferencing?
If you're using intra-only, it's a 1-frame latency if you're using intra-only.
Yeah, okay. And if you use like, if you want to, I think to replace it, H.264, that's my right.
I'm not too sure about that. Can anybody else help me out with it? Or?
Since you're with intra-frame only, you don't have good compression, but you could have really low latency. But then for video conferencing, you would use some larger to get a bit of motion competence. So you could use it. More a question of encoding speed. Current CPUs are. You can only do low resolution, and then Dirac is only. Is targeted more high resolution on it. So
No, if you use the long op, I think the maximum, at the most, is a latency of 4 frames. I think, yeah, with the long op, yeah, it's just still a latency of 4 frames. Yeah.
Is it possible to use interframes, but only predicting back to the previous frame?
Yes, you can. Yeah, the GOP structure is very, very flexible, so you can have. Yeah,
So
it could be
I guess
anywhere.
if it gets a balance savings, it's still
Mhm.
maintainable.
Yes.
Yeah, use the redundancy.
Yeah, you can work it out.
I think I managed.
That's good also. So yeah, there's a slot there.
All this video stuff's draining my battery. Better safe than sorry. Okay. Am I supposed to speak into this? Yeah? Is that where you're recording? Cool. Awesome. Okay. Okay. Let's get started. Video accessibility is my topic for this morning. I've done a contract for Mozilla on this for basically the last 4 months, and I'm going to continue working on this because it's a really big issue. The biggest problem is really that we've got the HTML5 video tag. Jan showed us a few examples before of this. I've written down what it will basically look like. You've got a video tag. You specify the source of the video as a resource. You can specify a thumbnail through poster also as a resource, and then you've got a few more attributes for the video tag. For example, the controls automatically display video controls inside your video tag. Autoplay specifies whether it should start autoplay or not. And so this is an example of the video tag. Now, of course, getting video into a web browser means that we will have the same issues that we have with web pages and more recently with Ajax stuff. of accessibility, in particular to the disabled community, basically the blind and deaf community, but it goes a bit further than that. So what about accessibility for video? I'm starting here with the obvious ones, which are captions, of course, for the deaf, but also you need captions in light environments when, for example, you're at an airport, there's lots of stuff happening around, you want to watch a video, a movie. It's actually very handy to have the captions being displayed there and be able to watch the movie without actually hearing what's going on. And subtitles is a similar thing, while subtitles actually have more of a focus on internationalization of videos, meaning if it's in a German video and you actually want the English subtitles for it, then that's what they do. Not so much from a deaf or from a hearing impaired point of view. I have a little video for you here, and I'm trying to make this a bit more interactive through some videos, so you can see better what I'm talking about. Here's a very cool video, and can't really hear it because I haven't plugged this up to any sound equipment, but we don't need it because we're really talking about... Oh, we can hear it. But we've got subtitles on this one, and these are subtitles in English, which are just a transcript of what he's saying. But Google have done a pretty cool thing. They, with YouTube, they are also providing subtitles in Spanish, which you can... You're supposed to be able to start. Yeah, here you go. These are subtitles in Spanish. They've done something that's even cooler than that. They've created a translation service on here, where you can say, for example, take the English subtitles and translate them into a whole swag of other languages. Come on. No, I'm going to translate this into German because it's very funny. Unfortunately, most of us won't understand it, but that's okay. So here we go. It's automatically translating it, and Jan will probably start laughing very soon. But we can do that for other languages. Anyone got a specific language they prefer? English. From Spanish to English. Come on. No, it's not talking to me anymore. Ah, here we go. Translate from, you want Spanish, into English. Let's see what happens. That's not too bad. Yeah, automatic translation is still a bit tough. I'm actually using it in my blog feed and on Google Reader when I come across some foreign language blog posts, and I'm going, this could be interesting. So I get it translated. It's often a bit off, but you get the gist of it. So it's actually pretty useful. It's useful here as well, even though it might not be perfect. But you get the gist of what captions and subtitles are about and how important they really are, in particular if you can hook it up to something like the translation service. I basically tried to outline that before. Captions are really more from a deaf or hearing impaired point of view. You have to transcribe everything. You have to transcribe sounds like closing a door, anything, music, anything. Whereas subtitles are really for people who can hear but who don't understand the language. So it's more an internationalization point of view. From a display point of view, as you've seen, they're both in the same position normally. They're text that's overlaid on video normally. So from a user's point of view, it doesn't actually make much of a difference, but from a hearing impaired point of view, it makes a huge difference if you actually get the sounds transcribed as well. Other accessibility things are for the blind, for the deaf also, the use of sign language, and I've got some examples here as well. So here's somebody signing, and She's signing, what movies would you like to see? I don't know what's playing. Learn how to sign language around the town in this free education video. Yeah, so she is teaching sign language, and often you've seen these kinds of things as a picture-in-picture video for people who are deaf. The important thing about signing is that sign language is a language of its own. It's not actually a transcription of what is being said in a particular language. There's just as many sign languages on this planet as there are human languages, but they do not actually overlap in areas. They can have, they can be in different areas. So a group of, might be that all North American people are sharing the same sign language, but it could also be that there is a group of people who have developed their own signs, and so sign language is actually a whole area of themselves, of itself. So what do we do with sign language on computers? Well, we might want to represent sign language as well, because sign language is for the hearing impaired actually much richer than natural language, because it also transforms a lot of the emotion that's being said, not just the words that are being said. So here is an example of a voice-to-sign language translation technology that IBM has developed that could be used in future to automatically transcribe stuff that's being said in sign language. There are also other ways where people have tried to use avatars for transcribing, where there is actual text available for transcribing it into sign language. This is an example. It's I'm going to stop your fun here. It's actually being used to some extent on websites. Here, for example, this website has a very interesting way of navigating. Come on, show me something. Here we go. It's the internet. Oh. Thank you. It wasn't too bad yesterday. What is it? I'm not getting my session. One last try. If this doesn't work, I'll give up. Here we go. So here, they've actually included sign language into the website, and the sign language is describing what you're looking up, the assistive devices area here.
She's sort of the headline.
She's basically the headline, but in sign language. So these are things that we want to and need to support in, oh dear, I think I need to reload that one. That we want to support in video accessibility for the hearing impaired. Now, there's of course also the blind community or people with problems with seeing. Also, think about if you've got an eyes-off application, you're working somewhere on a computer and there's a video playing in the background. It'd be quite nice to actually be told what's happening without having to turn around. And if this video works, I've got something to show. Don't tell me they removed it since yesterday. Give me more tubes. Seems to be loading.
Audio description is a service for people who are blind or with visual impairment. A commentary track has been added to describe the action on the screen. Audio description is available on selected television programs, cinema films, and DVD releases. The following clip is from the digitally remastered feature film I Bought a Vampire Motorcycle, available on DVD.
Have to have
Warning,
some fun.
this scene is rather disgusting and may not be suitable for people who've just had their lunch.
You'll come this way, so the inspector will see you now.
Inside, the flat is in chaos. There's blood and tyre marks all up the walls. A plainclothes officer picks some bits of meat up off a dado rail with forceps and puts them in a plastic bag. All the furniture has been smashed to bits.
Sounds even worse with audio description, to be honest. More scary.
Jaunty sort of audio description as well. Doesn't follow the mood of the scene.
No, that's actually a very typical thing for audio description. It just tries to be neutral. It tries to transcribe what's happening in the scene without going into any emotion. And that's actually sort of a pretty good thing, because you can think about using audio descriptions as text and then them being read out through a screen reader. Screen reader doesn't have any emotion either. So it could sort of work. The only problem is that you have to really be careful when to place your audio description time-wise, because you don't want it overlapping with the actual sound in the video, the actual speech in the video. So there is some challenges here that you have to think about if you wanted to replace the extensive effort that goes into creating audio transcriptions, audio annotations by people through some text-based mechanisms. Of course, another way to do the text-based transcriptions, just going back here, is through using braille. So if you had some textual annotations of the scene, then you could have them to a braille device, and then people could listen to the scene and read what's actually to be seen through the braille device. Anyway. Let's move on. I just wanted to give you a brief taste on all these accessibility things that are possible. My main focus has actually been text, using text to help accessibility in video. And for sign language and audio, where we actually have media, the solution is to multiplex it into OGG, to create a multi-track Theora video, for example, where you have multiple video tracks for the sign language and for the actual video. Or for the audio annotations, to use multi-track Vorbis, you would have actually probably use Vorbis for the sound from the video to get all the frequency ranges, and Speaks for the speech transcript, because that's only speech text. Then you have to think about rendering defaults. And ultimately, of course, you also have to think about content selection and adaptation over the networks. If you've got video on a server and you're on the client, you don't always want all the video tracks. For example, if you're not visually impaired, you might not want the sign language track. So you don't want to actually have to pay for that bandwidth. So there's a bit of a challenge here still to be investigated. So as I said, alternative is to actually use text for these things. Text is a lot less to transport over the network, so would be a lot more useful. Can also be used by a lot more devices. Google could use it to index into videos and things like that. So captions are a big alternative to sign language, and textual audio annotations can be rendered to braille or screen readers. Text is my focus. To give you a bit more of an impression what we're dealing with here, I've taken some example of existing file formats. So this, for example, is an SRT file, a subrip text file, which is actually one of the standard formats being used in the subtitling community, the online subtitling communities. And you can see they number through all of their captions. There's a time, start, end, and then there's a bit of text. That's basically the way that these SRT files look like, and you would think that it'd be fairly simple to support that in web browsers. Rusty?
Why is there an empty zero?
At the beginning, I think they want to cover, in this particular example that I took, they wanted to cover all of the video with yeah.
In this particular example, the reason for adding this subtitle, an empty subtitle in the beginning, is a bug in VLC that caused the first subtitle to disappear. So by adding an empty subtitle in the beginning, all subtitles that are important are displayed.
Ah, good to know. I did steal it from you. Sorry?
Have they patched VLC yet to stop dropping the first subtitle?
I haven't checked.
It's obviously bugs that we need to report to VLC.
If you want to get something out, you have to work with the existing.
existing software, yeah. So, and we go into Jay's example. I stole this from Jan. Here. This is the example. So how do we use the existing video element together with subtitles? And Jan has made this little example. Here's a video element that he used, and here is the SRT. Yeah, that's the SRT file, and he's getting from. He's put that into a div tag, and he's got some JavaScript libraries around that, which make sure that it actually works together. So here, if we play this video, it should play. Is it playing? Yep.
There were princes. They were absolute regimes. The degree of absolutism was relative to the particular setting. But if you take France as the most important...
Never mind. So as you can see, the subtitle is just displayed underneath. This is just using standard functionality in a web browser. And I think that's a pretty cool example. Now, of course, this is one way to put subtitles together with a video. It's an ad hoc way. It's using JavaScript. It is working, and it's in fact Ian Hickson's preferred way of doing subtitles at the moment in a web browser. Ian Hickson is one of the driving forces behind HTML5. I sort of disagree with him here a bit. I would prefer us to specify in the standard from the start a way on how to associate subtitles with videos in one way and not come up with like a multitude of different incompatible ways of doing it, which is why, come on, do it, here we go. Which is why I've posted an out-of-band proposal for video subtitles and in general time-aligned text to the HTML5 working group. As you can see here, we've got the video element still, but inside the video element we've got these text elements, and they may still be renamed to something else, but for now I called them text. I've given them a category, so these ones here are closed captions, these ones here are subtitles, and I've given them a language attribute, so we know which language they represent, so that the browser can actually display the different languages as alternatives, and a source file. So in this case, here's an SRT file. Here is actually an DFXP file, which is W3C's time text format. There's a SMILE file, which is another format of that is being used to specify subtitles. And down here, I used a web service, like the one that I demonstrated just in the YouTube demo with President Obama, where they have that as a web service, the translation service. So that's my proposal to do it. Interestingly enough, Michael seemed to like it and implemented it into MetaVid. So here's a little example that is using this kind of specification, and he's got his closed captions here on the side. So as you can see, there's a multitude of different ways of also displaying closed captions. He's using it to jump, to navigate. I think I have a problem right now with the display of this. Let's just say there's a bug. Oops. Anyway, so that's what we specified, and even though there isn't much support in the HTML5 community yet, there also hasn't been much people screaming this is all wrong. So I think what we're doing is we're going to continue along this path, explore this a bit further, do some implementations in the Mozilla web browser, and maybe have this working in 3.2 or something, or Firefox, so people can experiment with it and see if that works for them. Now this is an out-of-band proposal for video, which means it's not inside the video stream itself, it's a link, and the web browser does the synchronization between the two. Of course, people have been asking for inline in OGG as well, which is more important if you're trying to exchange video files with other people, because you want to have the text directly inside the video and not have to deal with a multitude of other files as well. Otherwise you end up with what we have with web pages, a web page and 50 different files that belong to it in order to display the web page properly. That's not what we want with video, which is why here we're currently working on multi-track OGG with an SRT track. We've got specifications for it. Initial ones. OGG text is here. It is a draft, but it is a very well worked out draft, and we're working on implementing it. OGG text is a generic way of mapping time-aligned text into OGG. We've made sure it's generic enough to allow overlapping text, because we might have multiple tracks that overlap in time. For example, think about having a speech bubble on the top right and the speech bubble on the bottom left over your video, because you want some annotations, and one will turn up, and then while that one's still on, another one will turn up, and then that first one will disappear. So they overlap in time, and you've got to make sure that you can map that into OGG. So we've created this generic specification for mapping text into OGG, and then a more specific one for SRT. These are things that we're currently working on implementing. Expect some better demo next year. I will probably put a paper into the proper conference for this. Here we go. As I just mentioned, there are other things than just captions and subtitles, and maybe time-aligned text annotations. Time-aligned text can be, for example, lyrics. Lyrics is for sound, for music that you want to have transcribed. Karaoke is similar, but you actually want to sing along, so you have to have this consecutive coloring. Ticker text is a very famous time-aligned text. Over your video, you see it constantly on TV when you watch financial data. Generic annotations, like the speech bubbles that I mentioned before, are typically used in Web 2.0 applications. Transcripts, of course, for any type of video, we often have transcripts that we want to time-align and display with the video. Linguistic markup, so the linguistic researchers go down to syllable level sometimes in order to transcribe their videos. It falls into the same category, so why not allow them to do it with the same technologies. And metadata, which is often not displayed, but being used by automatic tools in order to find out more about a video, being, for example, which keywords are aligned with which sections of the video. For the lyrics, this is an example lyrics file. So there are some file formats out there that support these application areas. This is a lyrics file. Title, Let's Twist Again, artist, Chubby Checker, or Pure Beatles. Author written by Carl Mann and Dave Apple in 1961. Album hits of the 60s, and then the lyrics look like that. They begin at 12 seconds, and then at 15.30 seconds there are some more. So that's how lyrics are specified.
I just wonder if you can sing it.
You want me to sing it? No, it's too early in the morning. I'll give you some music. I have a karaoke file here. And karaoke is interestingly done using MIDI. Here we go. You'll have some fun with this one. You hear that? To try and please me. Do you think that would be fun? I think it would bore people to death. But it's an interesting. At the end of when everyone comes up the front and helps. Oh yes. See, MIDI is cool. Anyway, that's yep. Go away. Karaoke. These are you're going to think about all of these things as hacks people have done in order to satisfy a need they had. And somebody wanted to write some karaoke stuff, and there was nothing available. This was the easiest, quickest way to do it. It's just like the lyrics file. It's all suboptimal, and that's basically what I'm trying to get to. All of these things are suboptimal. All of these things attack similar problems. All of these things could be solved with the same richer language.
It should probably be noted, though, that the quality of the MIDI sound is as much to do with the quality of the original sequence and the software synthesizer used to produce it. You can get some really awesome stuff out of MIDI.
But it's very sort of very...
Well, it depends on how much you put in. Can we take this? Can we take this MIDI discussion offline? It's not quite the topic here, but MIDI is capable of stuff. Never mind. Ticker text. I actually looked up some ticker text examples, and interestingly enough, people have written JavaScript libraries to do ticker text using a .txt file, and the .txt file has this kind of stuff in them. Just a class, a hyperlink, and some stuff, and they then get displayed over time. So if you're interested in that, and I'm trying to speed up a bit because we're out of time. So if you're interested in that, just go looking for ticker text JavaScript, and you'll find quite a lot of different JavaScript libraries that do that. And this is a transcriber file, which is from the linguistics community. As you can see, that's an XML file. It's got some metadata at the top. Who is the scribe? This one is from an Eben Moglen presentation. What's the topic? The global software industry in transformation after GPL v3. Who's the speakers? What episode? What section? And then it starts here with sync time 0, sync time blah, and so on. And it references basically the speakers later on to show that this is now a different speaker. So each community has had to develop their own solution for basically the same problem. And going further, it's not just about time-aligned text. We can also think about active regions, which is what we sort of were talking about with CMML for the last 10 years. We want to have clickable text and clickable videos so that we can go into other videos when we are interested in digging deeper into topics, or to other web resources. Chapter markers also, you have an outline of the video and you can click on it and jump directly to cue points inside the video. So hyperlinks are another big thing that should really be put together with all of this. So who would guess what is the best language for text and hyperlinks on the web? Well, from my point of view, is it W3C time text? That's what the W3C has been working on for the last 10 years. The distribution format exchange profile looks basically like this. We've got a head tag, we've got a body tag, we've got metadata, styling, layout, and all of this is not, make sure to understand this, none of this is reusing HTML, none of this is reusing CSS, none of this is reusing JavaScript. It's all reinvented because it's an exchange format and it's supposed to work outside the web. Now I'm going, but what do we do in the web? We have all this functionality already available. And I'm sort of exploding to say, but why don't we just use HTML for all of this? So we can use CSS for styling, we can use JavaScript for effects. But we want time-aligned text, so we have to have some restrictions on HTML. And the only restriction I can really think of that is important is to have only a sequence of div tags in the body element and start and end attributes on those div tags. Then inside the div tags we can do whatever we need. We can do hyperlinks, we can do marked up text, we can do JavaScript so we have text appear over time as we need it in karaoke. All of these things. And that's the latest thing that we've been working on, as we call it TDHT, timed diffs in HTML. It's still a very, very early draft. We haven't got any implementations, but this is where we're going, what we're going for. It might end up, and this is something we've discussed in forums, might end up pushing start and end tags into the div elements of HTML by default, but we're not sure what effect that will have. So we're going to have to experiment with this for a while. But we're hoping that we can solve the problem of time-aligned text in the web space in a way that is actually web compatible.
I guess it'd be really cool too, because the transcription of the program would actually be the captions.
Yeah.
You
In one format, exactly. That's the idea. So then our next steps, and this is my last slide, is to first build a collection of example files, like the files that I've shown you, but a much larger collection, in particular around SRT, because we see that SRT is probably the most simplest and most adopted solution currently on the web for captions and subtitles, and so it's one of the first steps that we really need to implement and support. On the longer run, of course, with a richer format, and at the moment we're suggesting TDHT. So we want to implement that. In-band, inline and out-of-band. Inline inside OGG, and out-of-band as a associated file to video files. That can be OGG, but that can also be other files.
Who's we?
We, Mozilla. And the OGG accessibility group, basically. We need detailed specifications, so it's a long way off. It's only really started by the end of last year. Then eventually we will have to look at non-text codecs as well. What do we do with sign language? What do we do with audio transcriptions? And of course the big thing of content selection adaptation. That's a communication issue between client and server. What protocols do we support? How do we put that information forward and backwards? And how do we make sure that the servers can recompose the files? In fact, Conrad will probably go into this for a bit with OxyChop. Yeah, right. Not fully though, because we haven't fully explored the needs in that space yet. And ultimately, there'll be some standardization. And we're hoping that that can all happen in the next few years without too much of a delay. This year, the SRT stuff, because we want to solve something now that everybody can support, that everybody can subscribe to. And TDHT is, of course, a bit much of a longer story and needs a lot more discussion. That concludes my talk. Thank you. Questions? I've taken them during the... You've got another one?
Yeah, I was thinking, when you've got a video in a window and it's subtitled, you were saying the best way to subtitle is below the video. And I was thinking that when you make it go full screen, it would be really cool if you could make a transition from having it below, so it's not covering the video, to actually being blended onto the video.
I actually don't think I had mentioned which is my favorite display mechanism, but in fact that is one of the big things to investigate, which display mechanism for which type. So currently most people actually display subtitles and captions onto the video, which is fairly useful. Probably going to continue to be the favorite way of doing it. Underneath the video is a bit simpler, because when you're writing your JavaScript and things, you can just display it underneath the video. You don't have to make sure it stays on top of the video at the right position and things. So that's, if you want a quick hack, that's probably the easiest way to do it. But I don't actually have any personal preferences. I don't want to have any personal preferences because I want to look at the field from a neutral point of view. And it's not just captions and subtitles. All of the other things that I've talked about also need default display mechanisms. And so for default display mechanisms, that's one of the things we need to investigate. What is the best display mechanism for each? In fact, the subtitling community, the captioning center and so on, they have already long years of investigation into what is the best way to display captions such that a person can read it most quickly. And so I'll have to look into that research, and I'll have to analyze that and find out which would be the best proposal. Okay? I think we need to finish off because we're going into time of the next talk. Thank you.